Hi everyone, thanks for joining this presentation. My name is Gazelle Saniee-Monfared, and today I'm going to present 10-mode interactions exploring collocated multi-user interaction on a foldable device. This was a joint project between the Human-Machine Interaction Lab at Huawei Technologies and the Computer Science Department of the University of Manitoba. Traditionally, for collocated collaborations, users may hand over their devices to a friend to share some photos or actually coordinate their efforts across multiple devices, which often causes coordination overhead and privacy concerns. In this paper, we focus on a specific form factor of a foldable device, which we refer to as 10-mode. So the 10-mode device has two outward-facing displays, the primary and the secondary displays, and one display on top which sits between the two, which we refer to as the edge display throughout the paper. We seek to answer whether such a form factor can facilitate content sharing. For this, we designed a three-stage study. Throughout all studies, we use a foam board prototype with affixed optical markers to be tracked by OptiTrack cameras. We also have a ceiling projector, which basically displays graphics onto the prototype to make it look like more of an actual display. In the first phase of the exploratory study, we try to understand which applications users envision to use on 10-mode in a multi-user setting. Based on the data of the 13 participants that we recruited, applications such as galleries, YouTube, browsers, Google Maps, and Amazon were among users' top favorites. In the second phase of this study, we explore which sitting arrangement users preferred for each of the five applications. And in most cases, the face-to-face and L-shape affirmations were preferred over the side-by-side affirmation due to ergonomical factors. We recruited 8 participants for this phase of the study. Based on the qualitative findings of the previous study and the previous literature, we designed a 3-dimensional interaction design space specific to 10-mode. So the first dimension refers to traditional one-screen inputs. The second dimension refers to multi-display interactions that involve more than one display in them. And the third dimension refers to physical manipulations of the device, such as tilting the device to complete an interaction or folding it, and other manipulations. In the second phase of our study, we wanted to explore how users exploit this interaction design space in everyday life scenarios. For this, we designed a paired participatory design study with 14 pairs of participants. We defined 10 tasks representing everyday life scenarios, such as mirroring the gallery page onto the other side. The participants would take turns either as a mobile device owner or the one that the information is shared with. So here's an example of how participants were coming up with interaction techniques. On the right side of this slide, you can see a summary of findings. And for each of the 10 tasks, the most popular interaction technique by participants is provided by calculating the agreement scores. For example, for mirroring the display, the tilting action was the most popular interaction technique. In our evaluation study, we basically implemented those techniques suggested by participants and asked 6 participants to try them out and let us know about their feedback. So some of the findings are that like interactions that had elements of interacting on the edge display were favored by the participants because of the clean feeling of interacting on such a form factor. And users use the edge display both as a container and also a menu placeholder. Physical manipulations of the device are often employed when they do not cause distraction to the collaboration, and performing multi-screen gestures are preferred when the technique can be semantically mapped to the task. Thank you for listening, and please refer to paper for more details.